Works? Yeah. Cool. Thanks. Thank you for coming to my talk. Nice to see a full room. So, you all having a good conference, I guess? Yes. I don't see a lot of energy. Yes, it's better. I'm Deepu. I'm a Java champion, a part of the JHipster team. Anybody who have used JHipster? Yes. Okay, two people. It's not as popular as it used to be. It's fine. Yeah. I work as a developer advocate on Okta. I focus on AI security these days. Built a lot of open source stuff, polyglot developer, mainly Java, Rust, Go, TypeScript, and stuff like that. So let's begin. Let's begin with authorization. So authorization is the process of determining whether a user have access to a specific resource, right? And OAuth is the industry standard for delegated authorization. It's the only used standard for delegated authorization these days. But why? Why OAuth, right? So multiple reasons. Number one is enhanced security. OAuth is token based, so you're not you're not passing around credentials and stuff. You're mostly dealing with tokens, which means you also reduce the risk of credentials being exposed and stuff like that. The scopes are limited. Durations, I know you can adjust durations and stuff, so it's limited in that aspects as well. You can have refresh tokens and stuff to extend sessions and stuff. So being token based has its advantages. It's all completely TLS based, so it's secure that way. There is a lot of concept of least privilege in OAuth, so again, much more secure. It's also standardized. It's an open standard, which means it's highly interoperable, so you can easy to integrate with other services. So anybody implementing OAuth 2 services, you can easily integrate with other OAuth 2 services as well. So that makes building stuff and integrating with other services much more easier. It's also flexible and scalable. So there's a lot of lot of use cases. You can use it on web, you can use it on mobile applications, you can use it on smart TVs and stuff, for IoT stuff and AI agents and stuff. You can use it for a lot of use cases. So it's highly flexible and also scalable. It scales very well. It's cross-platform, so you can have applications in different platforms and all use OAuth 2 as well. It has a good user experience, especially if you are building stuff like social login. Users get a very familiar experience across different services because they might be using the same social login across services. That gives them a more familiar way to log into your application. It also reduces the risk of phishing and stuff because they are more familiar with a particular type of social login, like login with Google, for example, right? So if the more you're familiar with it, the less chances of you falling for phishing and stuff like that. Also, widely adopted. That makes it easier to build services around it. So that's why OAuth, and that's why OAuth is the most popular one. So let's go a bit deeper. So OAuth had multiple versions. We had OAuth 1.0, but we never talk about it, so let's not talk about it. We had OAuth 2.0. So I think most of the systems in practice, like or in place, or most of the implementations currently in place are probably OAuth 2 implementations. So OAuth 2 provided specific authorization flows for web, mobile, native, and different kind of applications. It also kind of allows you to grant access to third-party systems. So OAuth 2 kind of standardized the entire thing that what we know as OAuth. OAuth 1 is very different. We don't talk about it. The latest iteration of OAuth is OAuth 2.1. OAuth 2.1 built on top of 2.0, fixed some of the issues, addressed some of the security concerns and some of the complaints that was around OAuth 2.0. So that's the latest version. So if you're building something new, you should be considering OAuth 2.1. Let's go through some more base concepts. So in OAuth, we have the concept of system roles. So we have a resource owner. So resource owner is end user. So this is the entity that grants access to resources, or grants access. Then we have resource server. So resource server is typically your API server, and this is the entity that hosts protected resources. It could be access to an API, it could access to your database or whatever. So this is the server that hosts something that someone is requesting access for. Then you have the client or the system that is requesting access. This can be your own application, your own client application. This can be a third-party application, doesn't matter. So any client that is requesting access to a protected resource, that's your client, right? Then finally, we have authorization server. So authorization server is the system that authenticates the user and issues access tokens. It grants permission to the protected resource. And typically, an authorization server exposes certain endpoints. So it exposes a token endpoint, and it also exposes what do you call, like an authorization endpoint. So these two are bare minimum for an authorization server. So and in a typical flow, you pre-configure trust between authorization server and a resource server. So this is a one-time configuration. So this is where when you're building a new application, you set up a client ID, client secret, and you configure, right? Okay, this is the authorization server, this is the URL, this is my client ID, this is the client secret, so trust this, right? Or you set up TLS certificates or whatever you want. So it's a one-time setup. So once you have that, then there are certain flows that are typical. So you have a resource owner who visits a particular client. So it could be you or whoever, doesn't matter. Somebody goes to a particular client, wants access to a particular service or a particular resource, right? The client requests the user for access. The user should grant authorization. And when this happens, the authorization server asks the end user, do you consent for this request? In the authorization server redirects. Typically, it is a redirect where the user has to log in and provide a consent. So this is typically where, for example, if you're logging in with Google, this is typically where you get a prompt where it asks, okay, are you okay to expose your email to this particular service? Then you click yes, right? So this is where you are providing consent. So once that happens, the client now has consent from the user, so it can directly start communicating with the authorization server. So the client can send an authorization request to the server, it can get an access token back, and once it gets an access token back, it can use that access token to talk to the resource server to make API request or request to protected resources. This is a typical flow, but we have variations. We have flows for different scenarios. So we'll look at those. But this is like the base OAuth to system roles and definitions. So when you are dealing with any sort of OAuth to system, you will come across these four entities. So that these are the standard ones. Another concept in OAuth 2 is tokens. So OAuth 2 is all about tokens. So we have different types of tokens. So one is access token. So this is the token that is basically a piece of data. It doesn't have to be in a certain format. It's just a piece of data that represents authorization to access a particular resource. Typically, in practice, these are JWTs in most cases. It can be encrypted, unencrypted, doesn't matter depending on a situation. It can be an obscure token. It can be a plain text JWT. There are scenarios depending on which you would use one over the other. But in general, it's a piece of data that represents access or authorization to access a particular resource. Then we have authorization code, which is a short-lived token. And it is a short-lived token because you get an authorization code and you use it to, you exchange it for a access token. So it's a one-time use thing. So as soon as you exchange, it's invalid. So it's one-time use, very short-lived, only used in the authorization code flow. We'll look at that later. Then we have refresh tokens. So refresh tokens are long-lived tokens, which means a client can use a refresh token to keep asking for new access token. So if you have a refresh token, and refresh tokens also generally will have a validity, but you can also have it indefinite, for example, or 60 days or 10 days or whatever. You can configure it. Depending on the validity of the refresh token, you can keep using it to get new access tokens. And that is how you will have persistent sessions. For example, if you're logging into, let's say, a service like Google, you have a persistent session until you log out, right? Which means there is a refresh token being with the indefinite lifetime being used to keep getting access token, because Google uses OAuth 2 for all the authorizations and authentication. Refresh token generally has to be treated as a secret. So you're not supposed to keep refresh tokens on the client side. So you should always keep refresh tokens on the server side, because it is as good as giving someone your password. So it should never be exposed to the client. Another key concept in OAuth is claims. Claims are nothing but a key value pair. So if it is a JWT, it is a key value pair representing some data. It can be user information. It can be any custom data that you want to add to a token. It can be about your roles and permissions and stuff. It can be whatever. Basically, it's a key pair value representing some data. Another concept is scope. Scope is when you group like a bunch of claims together, right? It can be a scope. Scope can also be a permission or scoping something. Like, for example, let's look at an example. I have a JWT here. It's decoded. By the way, this is JWT UI, a tool that I built so that you can decode and encode JWT tokens on a terminal. In this decoded token, you have claims. So your audience, your AZP, EXP, these are claims because it's key value pair data. Then you have a claim, which is the scope, is also a claim. But the values in this inside scope can denote, for example, OpenID denotes a particular flow to be used. It says that this is an OpenID Connect flow, right? Whereas profile denotes that we want a bunch of claims in the response. So we want profile information of the user in the response. So scope can also be used to denote certain data to be expected back. At the same time, scope can also be used to restrict say permissions. Like this also kind of says that this is an OpenID, restrict this to an OpenID flow, right? So it can be used for those kind of purposes. And in most OAuth 2 based systems, in your identity provider or your own key clock or whatever you host, you can also do a lot of customizations. You can define logic to interpret certain scopes to, let's say, you can have a scope which asks for specific specific roles or something like that, right? So you can do a lot of customizations here. Next, let's look at the concept of grants and grant types. So this is the most important thing in OAuth 2, grants and grant types, right? OAuth 2 had a couple of grants. So there was a grant called authorization code grant. So authorization code grant is when a server issues a short-lived authorization code and your client uses that code, exchanges it for an access token, and then uses the access token to talk to a resource server. This grant is meant for applications that can securely store the client secret, because you need to pass the client secret when you request, when you trigger this grant, which means you can only use it for applications that has a backend. You cannot use it for single page applications. You cannot use it for mobile applications because you cannot trigger this from a client, because you need to store the client secret somewhere, and client secret is as good as giving keys to your kingdom, right? So you cannot have it there. So it is meant for secure clients. Then we had implicit grant. So implicit grant was meant for non-secure clients, or like single page applications, mobile applications. So this is where you can get an access token directly. You don't have to exchange an authorization code and stuff. You send a request, you directly get an access token, right? Then we had client credentials grant. So client credentials grant was meant for confidential clients, as in like the two systems talking to each other in an intranet, for example. So client credential grant was meant for API communications, intra-system communication. A user is generally not involved here. So an access token, you will get an access token without any user interaction in this flow. Basically, you send your client ID, client secret, and you get an access token. So finally, we had resource owner password credentials, very weirdly named. It's a mouthful. But basically, it was an emulation of a standard username password flow. So a user comes in, gives their username and password, and you send that data in the request to get an access token directly. This was heavily criticized because it was unsecure. It didn't have any of the advantages of using OAuth 2 because you're just emulating a standard username password flow kind of thing, right? So it was criticized. Hence, in OAuth 2, a lot of these things were dropped. Oh, takes a second. So OAuth 2.1 dropped implicit grant, dropped as in deprecated implicit grant and resource owner password credentials grant because both were criticized for being a bit unsecure, right? They didn't live up to the hype of OAuth 2 being very secure. So these were deprecated, and some changes were made to the authorization code grant. So authorization code grant was updated as authorization code grant with PKC. PKC is proof key proof key for code exchange, PKC. So the reason this was done, or why this could have been done, is like to do PKC, you should have a browser that supports web crypto, and only modern browsers support web crypto. Once we started having major market share for modern browsers, and once Chrome and Firefox and all these become the standard, and once we got rid of Internet Explorer, this was possible. Before that, it was not possible because you cannot do PKC on Internet Explorer and stuff. And a lot of folks, pretty sure a lot of folks still are stuck on Internet Explorer somewhere in the world. But with modern browsers, PKC is possible. You can create crypto hashes, and you can create PKC key pairs on a browser. So this became possible. So this update was done, and with the addition of PKC, authorization code grant can now be used for secure clients, like usual, like the old way. But you can also use it for SPAs. You can use it for native. So which means you can completely replace any use case for implicit grant with authorization code flow with PKC. And because of that, PKC is recommended for all use cases when you use authorization code flow, regardless of if it is secure or unsecure client, doesn't matter. It's always a good idea to use that because it adds a layer of security, and it doesn't cost much in terms of latency or computation or whatever. Resource owner, that was just not needed, so it was just deprecated. It's like there is no reason to have this flow at all. So client credential grant is still the same. It's secure because it is for confidential clients. Nothing to do there. There are also other grants. For example, there is a refresh token grant, which is only used to get access tokens using a refresh token. So this is basically a backend thing that when you have a refresh token, you periodically exchange it for access tokens. Then there is a concept of extension grants. So this is how you have custom grants, because OAuth only defines these grants in the spec. So for all other use cases, we have extensions grant. There are some popular ones. For example, popular ones like there is device authorization code grant. I'm pretty sure every one of you have used this. If you have used Netflix or YouTube on a smart TV, then you have used this flow to sign in. Then there is token exchange grant, basically for systems to exchange tokens. There is a new one called client-initiated back channel authentication, or CIBA, which is mostly aimed towards AI agents and this clientless systems which can trigger authentication flows and get asynchronous consent from user. So it's an asynchronous flow where user can decide to, give consent whenever they like, and the flow will adapt accordingly. So let's look at each of those flows and let's understand how it works. So implicit grant flow. Implicit grant flow, again, not recommended. The only use case for this now would be if you're supporting a legacy browser that doesn't support web crypto. That's the only time to use this. But the flow, again, if you notice, the entities are the same across all the flows, and most of the flow is very similar, and you would start noticing some patterns between certain flows. So every flow will start with the resource owner. The resource owner is going to request for a service from the client. The client is going to trigger a request to the authorization server. So in this example, if you see, I mentioned two endpoints, right? There is going to be an authorization endpoint and a token endpoint. So in this flow, the first request goes to the authorization endpoint. And if you look at the payload, there is a specific item called response type. And that denotes that this is an implicit flow. So if your response type says token, then the server understands, okay, you're running an implicit flow and you're asking for a token. So the client, the resource server then triggers user authentication and authorization. So if you're already logged in to that system, then only the authorization will be triggered. But if not, you will log in, then you would see the consent screen. A consent screen is almost always mandatory, so you will always see the screen where it asks, okay, this service is asking for this information, maybe email, or maybe email and profile, or birthday, or whatever. It's asking for this information, and it is asking for these permissions on the system, like read, write, or just read, or whatever, right? Then you consent. Of course, if you don't consent, then the flow is cancelled and nothing happens. If you consent, then the authorization server responds back with an access token to the client, and then the client can use that access token to access the resource server. Again, authorization server and resource server can be the same system, can be different system, doesn't matter. It's just the concept of that. And in most practical implementations, they are kept separate. It's also a good idea to keep them separate, especially if you are using an IDP like Auth0 or Okta or Keycloak or something like that, then it's separate. That's your authorization server. Then you have your applications serving APIs and stuff like that. And if you notice in this flow, there is nothing happening at the token endpoint. There's no request being sent to the token endpoint. So that's the implicit flow. In the resource owner password credentials grant flow, I hate saying that name. It's very, anyway. It's pretty much the same. The resource owner starts the service or requests the service. The client sends a request, but not to the authorization endpoint, directly to the token endpoint. Because the authorization endpoint doesn't have a provision to send client ID, client secret, and these things. Token endpoint does. So it directly sends a token request. It includes the client ID and client secret in that, and the username password of the resource owner. And it says grant IP is password, which denotes that this is a resource owner password credential grant flow. Then the authorization validates all these details and responds back with an access token. The client can now use the access token to get services and provide the service back to the user. It's very simple, and I think you can see why it is not secure, because it doesn't do much of an OAuth thing. It's basically bypasses everything and just provides everything directly to the token endpoint, which means you are not just passing client ID, client secret, and username, and not just passing client ID and client secret, but also the password. So you are passing two secrets in this request. So if this gets intercepted, you are exposing everything. Not a secure thing to do. And if you do this within an intranet setup and stuff, maybe okay, but anything other than that, it's very risky. So it's not recommended. And there are no scenarios where this would be needed, actually. At least today, there's no scenarios to use this. Then the old authorization code grant flow, we have that. So again, the resource owner starts the request, goes to the client, asks for a service. The client sends the authorization code request to the first endpoint. And if you see the response type, it now says code, which means it's a authorization code flow. It could have been standardized better, the names. They're not very consistent if you look at it. There are some other metadata being passed, which is in most requests you will pass that, like client ID. The server needs to know which client is requesting this, where to redirect back once the flow completes. So you can provide a URL, and the server will send once it is successful, the server will send the user back to that particular URL. In most cases, your home screen or whatever. And your scopes, what scopes you're requesting, some metadata like state, if you want to maintain some state between sessions and stuff like that, all these things. So authorization endpoint gets that request. Now it triggers user authentication and authorization. Once the user consents, it will redirect with an authorization code. So the client now has an authorization code. Now it has to do another request. And when these things are happening, ideally with this, this should be happening in the back end of the client, right? It's not on your front-end JavaScript. You can do it, but shouldn't do it. It's supposed to be from the backend. So you get an authorization code. You now send a request to the token endpoint, where you would also pass your client secret, the authorization code, and you specify the grant type. Server validates that. Server will check if it is the same authorization code that it sent back. So it makes sure that it is the same flow. It will respond with an access token. Now the client can use that access token to get resources and provide the service. So this is secure if it is done as intended, like secure client. So you do all the clients, whatever is mentioned in the client. If you are triggering it from the backend, it's secure because you're storing your client secret and everything in a backend where you have ways to store them securely. So that's fine. So inherently nothing unsecure about this flow unless you use it for a SPA or mobile application, because then you would start doing these things from a front end or like a JavaScript or your mobile application, which makes it unsecure. So now let's look at the current flows and the ones that you should be using. So again, authorization code flow, it's very similar with some modifications. Let's see that. So the resource owner starts the process, asks for a service from the client. The client does an additional step. So it uses web crypto to create a code verifier and a code challenge. So that's the PKCE pair. So PKCE is like it's a unique pair where the verifier and code challenge are uniquely of a pair. So you can verify that they are of a pair, and you cannot create two pairs and mix and match and these kind of things. They have it's almost like creating what is it like the encryption pairs, right? Like, so they are of so with web crypto you can create and also verify that they are of they were created together, they are of the same pair. So that's how you do these validations. So the client creates that, and in most cases this can be done on the front end as well, doesn't matter. So that's how SPAs will do it. If you have a React application, for example, you can create this on the client side. If you have a pure Java application and if you are triggering this from the backend, you can do it with Java, doesn't matter where you do it. So you create that. Now you do a authorization code request to the authorization endpoint, and you can see that in red compared to the previous flow, you are sending a code challenge now. Along with all the other details, you are sending a code challenge. So the authorization server stores this code challenge for later use in cache or database or wherever it wants. It stores that. It triggers user authentication. It triggers user authorizations. Once it gets authenticated and authorized, it will redirect with an authorization code. So client now has an authorization code. It already has a verifier and code challenge. So when you create that, you should also keep it in cache or cookie or whatever, because you need it in the next stage, right? Now it sends a token request, and if you look at the token request, client secret is missing. You don't need a client secret anymore, because now you can send the code verifier, because you already sent the code challenge in the first request, which the authorization server noted down, right? Now you are making a token endpoint request, you are sending your authorization code, and you're also sending the code verifier here. So server will look at the code verifier. It already knows that this is for this particular authorization code. It would have made a note of the authorization code and the equivalent code challenge. So it will do a PKCE verification against those. If they match, then the server can be sure that, okay, both these are being triggered by the same client. So it's in the same loop or same flow. So now it will respond back after verifying that. It will respond back with an access token, and you can use the access token to call your protected resource, get services. Everyone is happy. And because of how this works, now you can use this for secure clients like a backend application. You can use it on a client-side application like a React application or an Angular application, for example. You can use it on a mobile application, doesn't matter. Regardless of where you use it, this is secure, because you are using a PKCE pair to make verifications, and you are not using client secret at all. So no secrets are being exposed anywhere, or so even if someone intercepts this, they don't get a secret. They only get maybe that one token, right? They don't get any secret to do any further damage. So it's secure. So the current recommendation is, for most use cases, you will go with authorization code grant with PKC. Even if you are using a secure client, it is recommended because it adds an additional layer of security, removes the need to store a client secret, which is always a good thing. Then we have client credentials grant. As you can see, there is one entity missing. The entity is resource owner, because this flow doesn't involve an end user, because this is meant to be for system to system communication. So this is a client can be a cron job, or just another system communicating with another system in a microservice environment. It can be whatever. It can be two systems talking to each other in intranet. One caveat or requirement to use this flow is that this has to be for confidential clients. That means two clients would trust each other. Or so most probably in intranets where you know that, okay, it's a secure environment, you can send sensitive data between two systems, then you can use this. Never for, I don't know, like from a client like web application or something like that. This should never be used for that. So here again, directly the token endpoint is used. So the client will send a request for access token. It will send client ID, client secret. Basically it's like just verifying with username, password, right? So the IDP verifies that and gives an access token. It uses the access token to get further services. It's simple. Then we have refresh token grant flow, which is a replica of what we saw earlier with the client credentials grant. So technically, refresh token grant flow can be considered, a confidential client thing, because refresh tokens are supposed to be kept in a secure backend, and this flow should only be initiated from a secure backend, because refresh token is almost as good as having your client secret. Because if you have a refresh token with indefinite validity, for example, you can keep getting new access tokens with that, right? So it should be treated as secret. So again, very similar token request, the additional thing being the refresh token along with client ID and client secret. So you pass that to the server validates, gives you an access token, you get a new access token. So generally this is done when, so in realistic implementation, how this would work is let's say you have a web application, let's say you have a Spring Boot application, you have implemented authorization code with PKCE, so your user logs in, gets authorization code, exchanges it for a token. So you get an access token and a refresh token. So you store the refresh token on the backend, you pass the access token to the resource server to get stuff. But generally, access tokens are short-lived. Like let's say the access token has a validity of 60 minutes, right? So after 60 minutes, when you are trying something, the client tries a request, fails because the access token expired. It looks at the error code, okay, access token expired. So it takes the refresh token, does this flow, gets a new access token, retries and gives you the thing. Again, you probably won't see that thing because whatever framework you use takes care of all that. For example, if you're using Spring Security, it takes care of token exchange and all that thing. So it's kind of obfuscated for you. So you don't generally see these things. But if you ever have to debug or something, then this is where you need to start looking into. Then one of my favorite flows, this is one of the most used extension flow, the device authorization grant flow. As you can see, we have an additional entity now. So in every other flow, we had the resource owner, client, authorization server, and resource server. Now we also have a secondary device. It can be anything, but realistically, this is going to be a mobile phone or a tablet or something like that, right? That's more real. It can also be a laptop, whatever, doesn't matter, a secondary device. So again, resource owner goes to the client, asks for a service, let's say a smart TV, you are trying to log into Netflix. You go to the Netflix client, it asks you to authorize. So the client sends an authorization request, but not to the authorization endpoint. This flow adds a third endpoint called device authorization request. That's why this flow needs to be supported by your IDP. A OAuth 2 IDP doesn't mean that it will support everything. By default, if an IDP is OAuth 2 compliant, that means it has to expose authorization endpoint, token endpoint, and support the basic flows. That's it. These are optional. So, but in reality, I think every IDP out there and every OAuth 2 provider out there will support these flows because it's very popular. But it adds a third endpoint. So it sends an authorization request to the device authorization endpoint, which basically just sends client ID and scope it is asking for. So the authorization server responds back with some information, like it sends a device code, it sends a user code and a URI, a verification URI. Now your client will pass that to the user. This is where in your TV you will see like a 4-letter code or a QR code or something and a URL. It will ask you to go to a URL and proceed. So that is what will happen here. So device code is kept by the client. It shows the 4 or 5-digit user code and the URL to proceed. The flow kind of gets cut off there because the secondary device is asynchronous, it's separate. Your client, once this information is shown to the user, the client will start a polling process. It will start polling the token endpoint. It will start polling the token endpoint, let's say every 1 second or something like that, right? It will keep sending the device code and the grant type, because it's an extension, it's a very long one. Extension grants are supposed to be in this format. So it will keep asking for this, and of course, in the beginning it is going to fail because there is, there won't be a token because the user hasn't authenticated it. So when it gets this, the server is going to check, is the user authenticated? No, it's going to fail, but you handle the failure and you keep polling for it. In the meantime, the user, because this is a manual flow, the user has to start this, right? So user looks at this data and opens the secondary device, goes to that URL, enters the code, and when that happens, the authorization server triggers user authentication and user authorization as usual. User gives consent. Additional step is done here. When the user gives consent, the authorization server, since it knows that this is a device authorization code flow based on the metadata, it will mark the user as authenticated in some database somewhere, right? So when this happens and the polling happens again, then the user is authenticated and you now can respond with an access token. So now the client got an access token. It can ask for more service using that access token and provide service. So this is the device authorization flow that you normally see in smart TVs and wearables or whatever. So this can be used for any situation where you have a user input limited device where it's hard to type in a password or something like that, or devices that don't have a browser, for example. So there is since we have so many flows, then there's this question that, okay, when to use which, right? When to pick which can be done with a flowchart very simply. So first question to ask, is your client public? If it's not public, then does the client have end users? If it doesn't have end users, then client credentials flow. It's no other option. If it is public and has end users, authorization code flow, with or without PKC, it doesn't matter. Ideally, I mean, it's not a huge thing to add PKC, so ideally with PKC, but can also be without PKC. Not a huge disadvantage, right? Okay, that's one. Now, so this was when your client is not public. So basically intranet applications and like stuff like that. Public client, yes. Is it a SPA or a native app? If it is an SPA, does the browser support web crypto? Or basically you're asking, are they using IE? No? Then yeah, the browser doesn't support web crypto, then implicit flow. That's the only time you would have to use implicit flow, which is extreme. I would assume it is extremely rare, but we have enterprises, we have old banks, we have government organizations. I recently was doing some paperwork for a government thing, and it didn't work in Chrome. So it worked in Edge though. So at least. So, there are still those cases. But if browser supports web crypto, then authorization code with PKC. Again, if it was not an SPA but a native app, then is your app UI or input constraint? As in, do you have a browser? Can you input something there? No, then you go with authorization code with PKC. If it is constrained, then you go with device authorization. So that's how you decide on these. There are no cases where you have two flows to choose from. They are all designed for particular stuff. So that's about authorization. Now let's talk about authentication. Of course, OAuth 2 authentication is the process of verifying some user's identity, right? Authorization is the process of determining if you have access to a specific resource. Two different things, right? With OAuth, OAuth didn't have any way to authenticate users, but that didn't stop people from using it for authentication. So when OAuth 2 started becoming popular, people started doing workarounds to use it for authentication. Then people were like, maybe we should have built that into OAuth 2. Makes sense. So OIDC or OpenID Connect was born. So OpenID Connect is a layer on top of OAuth 2. It allows third-party applications to verify an end user's identity and to obtain optional user information. And it typically uses OAuth 2 flows. So let's look at a typical OIDC flow. So I'm going to use authorization code grant flow because that is the most used flow for OIDC, but you can also use OIDC with implicit flow, for example, but extremely rare. So this is most common. So resource owner goes to the client, but now to authenticate instead of request some resource. So user wants to authenticate. Again, the client creates a PKC pair. It sends an authorization request to the server, authorization server. Everything is same. One difference being the scope of OpenID being added now. So this lets the IDP know that this is an OIDC flow. Again, OAuth 2 IDP doesn't have to support OIDC because it's additional. So if an IDP supports OIDC, it has to specifically say that, okay, we support OpenID Connect. Only then you can expect this to work. So when you send this, it will again ask the user to authenticate and authorize the request. Once that happens, redirect with authorization code. The client takes that, hits the token endpoint, again passing all the same. So this is same as in the authorization stuff as well, exactly the same. The only difference in this entire thing is sending OpenID until this point. Now the server responds back with 2 tokens instead of 1. It can be 3. Generally, it will be servers respond with access token and an optional refresh token. If you ask for refresh token, it will also send that along. In this case, it will always send an access token, an ID token, which is only for OIDC because that is the user's identity, and an optional refresh token. So it will send these things, and now your client can use the ID token to identify who the user is, because in an authorization request, user's identity is never revealed. An authorization request always only says if you have access or not. It doesn't say who the user is, what the user's email, it doesn't say anything about that. Only ID token will talk about identity of the user. So it will say who the user is, the name, email or whatever, and you can use that to, so now the user is authenticated and you can use the ID token, you can use the access token to get more user info, because OIDC compliant server will also expose another URL called user info endpoint, which provides more information about the user, but it is optional. So you can optionally request that to get more information, like a picture of the user, blah, 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 whatever. And you can use that for whatever user management purpose. So that's OIDC. So it's slight modification on top of the standard OAuth 2 flow. Then yeah, you can keep asking for, since you also got an access token, you don't have to reauthorize. You can start using other stuff continuously. I'm running out of time, so yeah, that's about OAuth and OpenID Connect. So this is the tool that I built. If you want to encode or decode JWT tokens, it supports signatures and all that stuff. You can validate tokens. You can find it here. It's written in Rust. It's open source. You can run it in terminal. It doesn't send any data over the web or anything, so it's completely local. What do I have? Yeah, So now you're a OAuth 2 expert. So now I hope you can debug OAuth 2 flows now. And if you're interested in advertisement time, if you're interested in auth for Gen AI stuff, visit us. We have a waiting list and some demos and stuff. We are building some cool stuff there. I'm working on a lot of security for AI agents and stuff. Cool stuff there, CBA and all. And if you want to try out all these things, we have a workshop for Java developers, OAuth 2 OIDC workshop. It's a Spring Boot microservice workshop where you will build an authorization, client, do OIDC, then do authorizations, tie everything together. So basically like a workshop thing. So you can try that out, and thank you.
Thank you, Deepu. We have a small gift. We've given away some money for Save the Children in your name.
That's so nice.
Do we have time for questions?
Yeah. If
anybody wants to ask something? Quiet. All right, then.
Either it was very clear or didn't make any